Welcome to the presentation of LAB, Learnable Activation Binarizer for Binary Neural Networks. My name is Falkena, and together with Hadi, Jamali-Rad and Jan van Gemert, we present you this paper. This research has been done for the TU Delft in cooperation with Shell Global Solutions International BV. The paper describes the need for a new activation binarization function in binary neural networks. So let's start with a quick recap of what a binary neural network does. A binary neural network is a CNN that takes binary input feature maps and binary weight kernel and computes a discrete value output feature map, which is then fed into the binarization function again. Normally, conventionally, the sign function is used as a binarization function. We argue that this sign function has an issue, being that if you have multiple discrete value output feature maps and you binarize them using the sign function, they map into the same binary output feature map, which is a loss of information. So we come up with LAB, the Learnable Activation Binarizer, which has a learnable binarization kernel per channel, hence the two channels, and it learns what value to take for the output feature map. So it learns whether to take -1 or 1. We apply the argmax operation, but because this is not differentiable, we apply the soft argmax operation in the backward pass. In our experimentation, we take 4 seminal BNN networks, and we replace the sign function with our new activation binarization function, and we see that both for top 1 and top 5, LAB improves the accuracy of all of those 4 networks while making sure that the model size is limited in increase and the latency is tolerable as well. We also compare ourselves against the state of the art, and we see that LAB-BNN is competitive in both top 1 and top 5 accuracy, and we also compare the number of operations as well as the latency on a real edge device. To give you an understanding of what LAB actually does, we have sign input, LAB input, sign output, LAB output, and we see that LAB is able to capture more of the texture, more of the features, and propagate those to later layers. This is all the channels of the first layer, and we see that this first layer already captures way more information. More examples of this are in here, and we can see, for example, that for the example of this lemon, that LAB is actually able to capture the texture of this lemon, albeit very roughly, but and also the same for the watch. You can see that LAB actually is able to distinguish the features in this watch rather than seeing the watch as fully in the same shade. I hope this gives you a basic understanding of what LAB works, and we hope you read our paper. Thank you for your attention, and love to keep in touch.